Going to look at the area of a circle and we're going to try to explain the origins of its formula. So you may be familiar with the idea that the area of a circle is equal to pi r squared. And so we're going to do a little arts and crafts to show how we got pi r squared and how that all works out. Now, a couple things I want you to keep in mind as you watch this video. First, the formula for finding the circumference, the distance around a circle, is equal to 2 pi r. And when I made all my circles, I kept this purple line on them so we can see that. So anytime you see a purple line, it is a circumference. Also notice how on both of these circles, I have a green radius line. And so anytime you see a green line, that is a radius. That will come in handy later. So as to explaining how the area of a circle is pi r squared, let's imagine doing something a little bit different. Let's imagine taking a circle and breaking it off into 4 pieces. If we break it off into 4 pieces, what we can do is maybe rearrange the pieces to try to get a different shape. Because if you didn't know what the area of a circle was, the best you could do is try to, make a different shape or make it to a shape that you could find the area of. So here, it's a little curvy, but if we take a look at what we have, what I'm just going to do is trace out the sort of the shape we have here. We'll see what we get. Oops, I kind of drew moved all the pieces. But what we see is the outline of a parallelogram. Now, you might say, hey, whoa, what about all that space? Like that's not being taken into consideration. That's not actually there. Same thing there. And that's true. That's a valid point. But what we're starting to see is if we take a circle and break it into different pieces and rearrange those pieces, we can get a different shape. So let's increase maybe how precise we can be with all of this. And instead of going with 4 pieces, let's go with 8 pieces. All right? And so now if we do it with 8 pieces, we'll see what kind of shape we will get. So I'm going to put them all together like this, alternating every other way. Okay, good. A couple more. This guy goes there. This guy goes there. And last but not least, this guy right there. All right, let's bring them all together. And again, what we're going to do is we're going to trace out our shape here. So might be a little bit off. This is random arts and crafts. I'm not a pro, just doing the best I can. But let's see what we have here. So again, I'm going to trace. It's going to be a little bit bigger than it actually is. That's okay. Just to help us get an idea of what this looks like. All right, and so what I'm seeing here is definitely a much, much better parallelogram. And so we're slowly getting to a better shape, a shape that is easier to find the area of. And you can even see it's a little tight. If I wanted to, I can make it much, much tighter along the blue lines or the purple lines. And we're getting really close to what the circle was. And what I want to remind you of, or what I want you to think about, is what's the base of this parallelogram? All right, so keep in mind, the purple lines are all the circumference. We have 1, 2, 3, 4, 5, 6, 7, 8 segments, but the length of this one is made up by 1, 2, 3, 4 of those 8 segments. So the length of this is half of my circumference. And now I got to try to figure out what the height is of my parallelogram if I want to calculate the area. And to do that, I'm actually going to do a little bit of mathematical magic, if you will, and we're going to have some fun. I'm going to take this piece, I'm going to cut it off. Now the purple, I'm going to cut it in half, I should say. The purple line is supposed to be a part of the circumference. The green lines are a radius. And so if I make it look like this and I retrace my shape, I'm going to have a slightly different shape. I'm going to have a shape that I think we're much more familiar with. So let me clean that up here. All right, bring this down, bring these guys down, bring all these guys down, bring these guys down. All right, and now we take a look at this shape here. Oh, excuse me, having issues. Yeah. Almost there, almost there. Take your time, do it right. Try not to rush. There we go. And now again, I trace it, and what I'm starting to see is not a parallelogram, but actually a rectangle. And remember, anytime there's a green line, that is a radius. And so the height of my rectangle, my width, whatever dimension you want to give it, is actually equal to r. And so now let's calculate the area of this rectangle, which is length times width. So that's going to be 1/2 c, 1/2 c times r. And I'm going to go back to this circle right here. The circumference is equal to 2 pi r. So I'm going to substitute 2 pi r in for circumference. So 1/2, and instead of saying c, I'll say 2 pi r. I'll times that by r again, so I'm just bringing down that other r. The 2 and the 1/2 cancel each other out. And what I'm left with is pi times r, which is r squared. And so that is roughly how mathematicians got to the formula of a circle. And imagine if we were to continue to cut these into smaller and smaller segments, what we're going to get is a much, much better rectangle. But the premise is still the same. The outside pieces are all going to be the circumference. And we're eventually going to get a rectangle where the base is still 1/2 c and the height is r. And so we multiply that together because we know how to find the area of a rectangle and we know what the circumference is. We can find the area formula of a circle. A is equal to pi r squared.